Okay, class. Regarding the calculations, okay. Now I took out a few of the examples from the textbook. All right. Okay. The question number one. Oh wait, let me expand this first. Okay. Question number one. All right. They already tell you. Okay. ABCD is a parallelogram. So you need to remember what are the characteristics of parallelogram. Okay. Okay. But wait first before we do that. P is a point on AB in such that PAD is 110, so they already annotate for you. And PC equals to BC. PC equals to BC. So we have an isosceles triangle here. Okay. So how do we calculate ABC? Okay. Now remember when we talk about parallelogram, opposite sides have the same angle. So here is also 110. All right. And then so we know which basically means also if this is parallel to AD is parallel to BC, means ABC plus BAD equals to 180. So to find ABC, all we need to do is 180 minus, this is supposed to be 110, 110 equals to 70. Okay. We found textbook error. Okay, next we need to find DCP now. DCP. Let me get rid of it. DCP. Okay. So first thing first, we know here is 70 already. Correct or not? And then, so how do we find DCP, right? Yeah, DCP. Okay. So since this is an isosceles triangle, here is also 70 degree. So we have two sides 70 degree. What's the total interior angle of a triangle? 180. So 180 minus uh oh minus 70 minus 70 equals to 40. So we can know here to be 40. Okay. Of course, if you realize it, this is parallel to this, we can get the z function. So we can know that this is also 70. But if not, you can also think of it as my way. Okay, since it's an isosceles triangle, so here we get 40. 100, this is DCB is 110. So 110 minus 40, I also get 70. Okay. Next, example 13. EFGH is a rhombus, okay, not a square, rhombus. All right. So rhombus have all sides of the same length, okay. And then given this is 100 degree, FEH is 100 degree. So that means here is also 100 degree, which means this is 80, this is 80. Okay. So we need to find FEM. FEM. Okay. Remember what was mentioned? What's the characteristic of a rhombus? The diagonal bisects the angle. So meaning, all I need to do is 100 degrees divide by 2. I get 50. Okay, because diagonal EG bisects FEH. Okay. Next, we need to find EFM. EFM. Okay. Similarly, since we can find that this is 80 degrees, the example is given slightly different, but never mind. I already found this is to be 80 degrees. Similarly, since it bisects, I can straight away get this one to be 40. Of course, you can use the textbook method also. It's not wrong. Okay. The textbook method is that this one is 90 degree. So we have already found here to be 50 degrees, right? So then internal angle of a triangle, total internal angle 180. So 180 minus 90 minus 50, you get 40. Also can. Okay. So when it comes to all these quadrilateral angle calculations, there's a lot of different methods. As long as it's legit and logical, can already. Okay. Okay. Last example. Now we are talking about a trapezium. Trapezium, all the angles, is it got relation or not? No. Okay. Now, in this case, all right, because it's parallel. Okay, that's the only one relation because it's parallel. Okay, this angle plus this angle will be 180. So we can see here 4x plus 6x equals to 180. So total is 10x equals to 180. X equals to 18. Okay, easy peasy. Next, we need to find the angle IJK, meaning we need to find this. Since we have x already, okay, there's two ways to go about it. You can do what the textbook show you. Okay, you find 7x and then you 180 minus that. Or you can, you know the total number of x is here is 17x, right? Okay, and this is equals to, oh sorry, 17x plus this unknown. Oh, you can find what is 17x. So 17 times 18, you get, what do you get? 306. All right. So 17x equals to 306 degrees. Total interior angle of a quadrilateral is 360. 360 minus 306, you get 54 also. All right. Okay. Thank you, class.